Welcome to the third video in our series, the projectile motion, where here our interest is to derive the formula for calculating the time of flight in a projectile motion. In our earlier two videos, we've taken time to define a projectile motion as the motion of a body with an initial velocity under the influence of gravity at a certain angle to the horizontal, and we found out that a projectile motion can be resolved into two components, the vertical component and the horizontal component, where we resolve the initial velocity into uy and ux. Okay, so, and we also defined some certain terms that included the time of flight, the maximum height attained, and the range of the projectile motion. Quickly, the time of flight refers to the total time interval between the point of projection and where the body comes to rest. And of course, the maximum height is the highest vertical distance attained by the body before it begins to curve. And the range refers to the total horizontal distance between the point of projection and where it comes to rest. So in this video, we want to derive a formula for calculating the time of flight of the projectile motion. All right, so let's hit the ground rolling. All right. Now, if we look at a body undergoing projectile motion, you'll discover that when it is fired at an angle, it begins to move with an initial velocity, and because it is under the influence of gravity in the vertical direction of the motion, gravity is having an effect. Gravity is trying to pull it down, so there will be a change in the speed or the velocity of the body. There will be a change in the velocity of the body. Okay, so that means as the body is undergoing projectile motion, it is in the vertical direction, it is actually decelerating. It is slowing down. It is slowing down. So at a certain maximum height, it stops temporarily. So let's mark that point here. So at this point now, it now begins to descend. So that's now why it now has a curved path. All right. Now, we are going to be leveraging on our equations of motion. What are equations of motion? I will just remind us of them. They are 1, V is equals to U plus AT. That's the first equation of motion. S is equals to UT plus half AT squared. That's our second equation of motion. And V squared equal to U squared plus 2AS. That's our third equation of motion. All right? Now, we're going to make some certain assumption. By the time from the diagram, by the time the projected body reaches its maximum height, we can establish that yes, it is halfway its journey, such that if it takes it 2 seconds to move from here to the maximum height, it naturally means that it will take it another 2 seconds to descend to rest. So in other words, it looks like the total time of flight, which is the time in between the point of projection and where it comes to rest, is twice the time it takes to reach the maximum height. All right? So let's say, let time to reach maximum, this is maximum height, let's represent it by small t, okay? So time of flight is twice time to reach maximum height. Okay, this is maximum. This implies that t is equals to 2t. All right. Okay, now let's use the first equation of motion, which is v is equals to u plus at. Now we're going to be making some certain assumptions. Since we are looking at the motion in the vertical direction, it means that we shall be utilizing the vertical component of the initial velocity. Actually, that is why our third video on the resolution of the initial velocity into its vertical and horizontal component becomes important. So I just summarize what we got there. Okay, when we are talking about the vertical component, uy is equals to u sine theta, and then when we are talking about the horizontal component, as ux is equals to u cos theta. All right, so of course, since we are looking at the vertical component, I'll be interested in uy. And of course, we've already established that as the body is moving up, the influence of gravity is decelerating its motion until it temporarily stops at the maximum height. So at maximum height, v is equals to 0 meter per second. And then also, the acceleration in projectile motion, we've already agreed that it is the motion of a body under gravity. So our acceleration will be acceleration due to gravity, where we shall be replacing our a with g. And then one more thing, gravity is a vector. It's a vector force that acts downwards. It acts downwards. If you jump up, the force of gravity pulls you down, so it's acting downwards. Okay? But as the body is moving up, it is like trying to move against gravity. Now, how do we show that? We're going to use a minus sign. So I'm going to say A is equal to minus G. All right? Now, if we substitute all this into the first equation, what do we have? We're going to have, okay, yes, what are we going to have? We're going to have V is 0 is equals to U. Our U is UY. That will be UY plus our A is minus G times the time of flight. But what is uy? Uy is u sine theta, so this is 0 is equals to u sine theta minus gt. Okay, so we could go ahead and begin to solve. So if we could transpose, this becomes gt is equals to u sine theta. Okay, so follow me. So we could just go to the top part of the board such that it will become clearer. So if I make t the subject of the formula, I will get t is equals to u sine theta over g. What have we just gotten? This represents the time required to reach the maximum height. Now we've already agreed that the time of flight is twice this time. So if the time to reach the maximum height is u sine theta over g, the time of flight is 2t, it means that t will be equals to twice of this, that's 2 times u sine theta over g, which will now be equal t will be equals to 2u sine theta over g. So this becomes the formula for calculating the time to reach the maximum height. Right, viewers, this is where we're going to stop in this video. I hope you've learned how to derive the formula for calculating the time taking time of flight in a projectile motion. If you've benefited from the video, please, I want you to hit the subscribe button, like it, share it with as many people as possible, and watch out for the next video where we shall be deriving the formulas for calculating the range and the maximum height. If you have any suggestion, if you have any questions, please leave it in the comment section. Thank you. See you in the next video.